Hi, I'm Elisa. I'm back, and we are going through the nervous system and we're looking at the brain. So, some of the basics that we wanted to go over this time include just kind of going back to that diencephalon on the inside or the interbrain part, the insular region. And also, I wanted to just kind of like introduce you to the idea of the meninges themselves. So, let's go ahead and get started. So, the diencephalon is the interbrain, and it consists of three gray matter areas, three structures, and they're in the inside, right? So you have to think of them kind of coming off of the brainstem as it enters in, and then the rest of this cerebrum literally folds like around it, right, and kind of like covers it up. So that's what it means when we're talking about like the insular region. All right. So the components to know about are going to be the thalamus, the hypothalamus, and the epithalamus. And so all of these are going to be enclosing the third ventricle. And if you remember a little bit about what we were talking about with the ventricular system of the brain, it's super important because it produces and distributes and also flushes through the cerebral spinal fluid, right? Which keeps the brain basically clean or fed, watered, right? So all that good stuff. So the third, oops, that was supposed to be an eraser and it wasn't. Right, so all that's third ventricle. So it's going to encompass that all itself. All right. So the diencephalon is actually, it's not very nice, but they used to call it the reptilian brain because it just like deals with the oldest, most common features of animalia, especially things like homeostasis, how alert you are, or if you're sleepy. Also, like, am I hungry and thirsty as well? It also is the sex drive and activity as well. And it's going to include the basic emotional components of the limbic system, right? So all of these things are basically survival level compulsions, right? Or drivers. So, yeah, so that's why they refer to it as the reptilian brain. It's like old ideas. I don't know. I don't love it, but that's what they did. Okay, so functions of the brain. The diencephalon itself has, like, let's just look at the thalamus and the hypothalamus primarily right now, and then we'll get into epithalamus in just a sec. I think of a thalamus as like the router of the brain. So stuff's coming in, stuff's coming out. So it's a relay station for all of the synaptic input, right? It does understand that there's sensation coming in and out, but it's not really useful that it understands what to do with that, is that it's a processing center for it, right? It's better actually that it just knows that it's sensation and passes it to where it needs to go. Because if it stopped to process it, well, then nothing would get past the thalamus. And so there is some degree of consciousness, some role in motor control as well, but not quite as much as the motor cortices of the cerebrum specifically. So hypothalamus over here. Hypothalamus regulates much of the homeostatic function, as well as things like temperature. Are you hungry? Are you thirsty? It's going to control things like, vasopressin, so urine output. Also food intake. Food intake. Wow, my hypothalamus must be so busy with that one. I love to eat. But anyway, so it's an important link between the endocrine system and the nervous system. So the endocrine system and the nervous system are both signals. So think of them as mail, right? You're getting your messages throughout the body. But the nervous system is like email because it's super fast, right? So it's like the email, like the text message of the body. And then you have endocrine, which is like the snail mail, which is still my favorite kind of mail to get. Still like my favorite. Endocrine system is like the snail mail of the body, so it's a little bit more hardcore, but it's like very tangible, and it can last oftentimes much longer. So it has extensive involvement with emotion and these basic behavioral patterns, right? It's very old stuff. It's a learning system, or it's the learning center, and it's dealing with a lot of these survival mode items. The epithalamus is like kind of interesting because we're looking at places like the pineal gland, And we're looking at that sleep-wake cycle that RAS is controlling. We talk about RAS in another video. Circadian rhythms for the most part, a little bit of emotion, but primarily the wake-sleep cycle. Right, so, and then the last thing I just wanted to give you at least like a little bit of an introduction and to kind of go over is the idea of the meninges. I know it seems like these two things are totally, they just like, they didn't sandwich well with anything else. And I thought, you know what, you guys, maybe opposites will attract. So I put them in together. All right, so the meninges lie just underneath the cranium itself. And so like, you know, here's this bisected cranium. All of this is like, you know, integumentary stuff. So the skin of the scalp, and then it's coming down and making contact with periosteum, which is just one of the protective, supportive layers of the living bone tissue. And then you get like the mothers, right? Mother, that's what it's like, mother, right? So the three mothers are dura. This is like tough mother. It is a tough mother. That sucker is thick. And so the dura mater is going to be like adjacent specifically to the periosteum. So it's like right next to or intertwined with the periosteal layer. And if you ever tried to cut through it with it's like cutting through a Glad yard bag. Like those black plastic yard bags. It's very thick, which is good because one of the things it has to do is it's got to bag your brain, but the other thing it has to do is it has to, like, you know, it's part of the support system that keeps all the cerebral spinal fluid in your central nervous system in your cranium. So after the tough mother layer, right, this nice thick heavy tough mother layer, we have the arachnoid, which is like the spider mother. Spider mother. Okay, and the arachnoid matter, like if you it's a matter. Right, if you look at it, it's kind of like web-like, right? So these little like fibers that are coming up here, right? And so they add a little bit of infrastructure so that we can have, you know, our blood vessels coming through, right? And also just a little bit of space for things like when we have, say, encephalitis, for example. Encephalitis is a condition by which the actual nervous tissue, glial tissue of the brain is swelling, as opposed to something like meningitis, which you might have also heard. So that would be like the meninges, that would be swelling and under pressure in that way. So anyway, so arachnoid matter is providing that infrastructure, that architecture for the vascularization. As you can see, it's not actually in the brain. It is the blood-brain barrier, right? And then the pia mater, so small, it's like little, teeny tiny mom, is just this like this last like thin layer right here. Right, resting on our gray matter proper. Okay, that's the pia mater right there. Let me erase that so you can see a little bit better, right? Yeah, pia mater. Okay, so those are the meninges of the brain. The meninges also extend all the way down to the spinal column as well, of course. So they facilitate the formation of the blood-brain barrier. They are protective and they act like a big bag around and under the skull cap proper. So there's a few just verbals that I wanted to give you. So the subarachnoid space is going to be that which contains the cerebral spinal fluid and the largest blood vessels of the brain, and we saw that, you know, kind of in that like crosshatch latticey area. The arachnoid mother, the spider mother, mater. Arachnoid granulations are kind of interesting. So they protrude. I'll see if I can, let me just get there. Okay. Right. So these like granulations kind of are what we're protruding out a little bit. So to show you that, there it is. Right. And so, especially in the superior sagittal sinus, right, that large cavity that's filled, with the cerebral spinal fluid, right, because it's a sinus cavity. It's just waiting to be filled up space. And so what that does is it allows for some of the reabsorption of cerebral spinal fluid back into the veins, right? So it's helping to take away some of that dirty, used up cerebral spinal fluid. Okay, so, hopefully you kind of enjoyed this, right? So hopefully this was a helpful lesson. And if you have any questions, feel free to drop by during office hours. Otherwise, I hope you're having a lovely morning. All right, bye.